Okay, welcome to Unit 4, Lesson 1, where we're going to be exploring number sets, domain, and range. So the goals here are to classify numbers into natural numbers, integers, rational numbers, and real numbers, and to identify domain and range from a graph and communicate that using proper notation. So first we'll talk about the number sets. The first set you're responsible for knowing is natural numbers. It's represented by the letter N, and it's all the whole positive numbers. So this starts at 0 and counts up in increments of whole numbers, sometimes called the counting numbers. The next set are integers, represented by the letter Z, and this includes all of the natural numbers plus negative whole numbers as well. So you can see that as some examples there. The third set is called rational numbers, represented by the letter Q, which is like quotient, and rational is like ratio. And so this helps you remember that these are all the numbers that you can make by dividing one integer by another. So basically any number that could be represented as a fraction of two integers. So this also includes whole numbers, as those can be divided by 1 or written as a fraction over 1. So you have to kind of think about anything that could be written as a fraction, even if we don't typically do that. And the last one are real numbers, represented by the letter R, and that includes all rational and irrational numbers. So this also includes things like pi or root 45. So basically, real numbers include all the numbers you are familiar with in your mathematical experience. So here are some additional examples showing you sort of things like what can be considered rational and integer. So 7 could be rational because it can be written as a fraction, etc. A key thing is that all terminating and repeating decimals are rational. So anything that ends, like 0.5, or repeats, like 0.33333, and so on, those are all rational numbers. So an interesting thing is how all these number sets relate to each other. So natural numbers are the smallest set, and that would be things like 1, 2, 3, etc. Integers encompass that natural number set. So they include all the natural numbers plus negative numbers as well, and so on. Then, encompassing integers and natural numbers, you have rational numbers, where you start including fractions and things like that. Notice that because the integers and the natural numbers are within the rational number circle, they are also considered to be rational. It's kind of like a nesting doll phenomenon. And then we have irrational numbers, which you don't need to know specifically, but those would be things like pi or root 45. And all of these numbers are included in the big set of real numbers. So the ones highlighted in yellow are the main 4 that you are responsible for knowing. So that's the relationship between the number sets, and you should be comfortable classifying numbers into these sets. So the second part of this video is about domain and range. So you did do some domain and range in grades 9 and 10. So remember that domain is the set of all values for which the independent variable is defined, which is typically x. Typically, the domain is always going to be all real numbers unless there are some restrictions. The range is the set of all values for the dependent variable, which is commonly y. So we use set notation for domain and range, and we'll look at some examples here. We won't do all 7 of these examples, but we'll do a couple. So anytime you see a graph that extends right to the edges of the plot, you can assume that that graph carries on forever, infinitely. So here, the domain, if you can imagine a piece of paper big enough, that line would go on forever, which means it would eventually hit every real number on the x-axis as a coordinate on that graph. So the domain is just x is an element of the real numbers, and the range would be the same. Now, if you look at the parabola on the far right here, now we start getting into some restrictions. So for the domain, you can see that the parabola would get wider and wider and wider. So eventually it'll hit all real numbers for x. However, there is a restriction on the y. So the domain is y, or the range is y, such that, so we draw a vertical line, y is a real number. However, y is also less than or equal to 3. So the whole function lies below the value of 3, but it is included on the graph, so we do less than or equal to. So we'll do one more example, which is the one in the bottom left here. So again, start with domain. Domain is defined as x. X is a real number, and the graph will continue to go on forever and ever at the left end, but at the right end, there's a fixed point at which it ends. And that appears to be at x equals 3. So here, x is less than or equal to 3 because the circle at the end of this graph, or the dot at the end, is closed. For the range, we have a minimum this time, so everything in this function is above the minimum for the y values. So the range is y is a real number, and y is bigger than or equal to -4. So here are some examples of the notation and how you can go about finding domain and range from a graph. So you should be able to do the remainder of the examples yourself, and hopefully you now feel more comfortable with number sets and domain and range.